Hi darlings, welcome to our video on isomers. So for today's video you'll need pen and paper for your notes, knowledge of naming hydrocarbons and functional groups, so making sure you go back to the homologous series video and the video on functional groups just in case you're still a little shaky on it, and then knowing what the expanded versus condensed molecular formulas are. The expanded formulas, the example of it would be this large one right here. It shows you how many hydrogens are connected to each carbon and pretty much where any oxygens are. The condensed molecular formula tells you the ratio of everything. So, to figure out the condensed molecular formula, we just have to count up the number of carbons, hydrogens, and oxygens from the expanded. So we'll take a look here. We have 1, 2, 3, 4, 5 carbons, 3 hydrogens plus 2 more, 2, and 3. So when you count that up, that should give you 12. And then we have 1 oxygen. So the condensed molecular formula would be C5H12O. So pretty much isomers are just molecules with the same formula but different structures. They have different physical and chemical properties since they do have different structures. And the more carbons you can have, or the more carbons you have, the more possible isomers that you can create. So an easy multiple choice question for this would be, which of the following has the greatest number of isomers? So just pick the one with the most number of carbons. Here's a first example. So it gives you the structural formula, and if you look at this, you should be able to recognize what the functional group is. And so here we have carbon double bonded to an oxygen and then an OH. So that gives us, if we write it out, COOH. And if you remember from the functional groups, that's going to be an organic acid or carboxylic acid. So I just wanted to kind of show you that to remind you. Whenever you look at these formulas, start to evaluate them that way. So what we want here is to figure out which is an isomer of the compound shown. So to remind ourselves, they'll have the same molecular formula, but a different structural formula. So they have the same number of carbons, hydrogens, and oxygens, but they're all arranged differently. So what we'll do here is just count up the number of carbons, hydrogens, and oxygens. So in the example we have 1, 2 carbons, then 1, 2, 3, 4 hydrogens, and 2 oxygens. Notice I'm crossing them off because at the end I want to make sure I've gotten everything. So we're going to go to each of the formulas below and just check to see what its molecular formula would be. So for A we have C, H, and O, and we'll just count up. There's 2 carbons, 1, 2, 3, 4 hydrogens, and then 1 oxygen. So this one can't be it because the number of oxygens will be different. Let's take a look at B. C, H, and O. We have 1, 2, 3 carbons. So automatically we know that the number of carbons are different, so the structure must be different, but I'll just go ahead and show you the rest of this. We have 1, 2, 3, 4, 5, 6 hydrogens, and 2 oxygens. Right? So B cannot be it because we have a different number of carbons and hydrogens. Let's take a look at C. We have CHO. So we have 1, 2 carbons, 1, 2, 3, 4 hydrogens, and 2 oxygens. So this looks like it can be it. Let's just double check. Let's take a look at D. We have C, H, and O. So we have 2 carbons, 1, 2, 3, 4, 5, 6 hydrogens, and 2 oxygens. So D cannot be it as well because the number of hydrogens is different. So C must be our correct answer here. Example 2 is which compound has an isomer of CH3OCH3. So here we have the expanded molecular formula that shows you pretty much where the carbons, hydrogens, and oxygens are. And we're going to go and write down the condensed formula. So we have CHO. We'll have 1, 2 carbons here, then 3 hydrogens, and 3 more will give us 6 hydrogens, and 1 oxygen. So A, B, and one of the choices from A, B, C, or D should match up to the same molecular formula. So pause me right now, go ahead and fill in the number of carbons, hydrogens, and oxygens for each one of the choices. Alright, so we'll have CHO. There's 1, 2 carbons there. There's 3, 4 hydrogens and 2 oxygens. So the number of hydrogens and oxygens will be different, so A can't be it. We'll take a look at B. We have 2 carbons. There's 3 hydrogens there plus 1 more, which gives us 4, and 1 oxygen. So B can't be it because the number of hydrogens will be different. Let's take a look at C. So automatically off the bat, you should kind of see that C has 6 carbons, so that shouldn't be our answer. But we'll go ahead and just count up the rest of them. So there's 5 hydrogens here, plus 1 more will give us 6 hydrogens and 1 oxygen. So C can't be it because there's too many carbons. Then we'll take a look at D. There's 2 carbons, there's 5 hydrogens there, plus 1 more, which gives us 6, and 1 oxygen. So D should be our answer. Sometimes they'll ask you to draw a structural diagram of an isomer of a compound. So this is when you have to go back through Table R, just remember how to draw out anything if it has a functional group, or use tables P and Q to remember which manga series it might be from. So let's first start out by drawing the actual structure here. We have dimethyl ether. If you go back, we should have an oxygen, and on either side of oxygen should be 2 methyl groups. Okay? So this is going to be what the original is. We want to draw something that's a little different. So when I do this, I usually just generally start out with a number of carbons and go back to my honk 1, 2, 3, 4 rules. So I have hydrogen has 1 bond, oxygen 2, nitrogen 3, and carbon 4. I want to make sure that I follow each of these rules. So I'll put down the carbons first, and I'm attaching it to one another because in the original they were separated by the oxygen. So I want to draw a different structure here. So this time I'm drawing the carbons together. I'll put the oxygen attached to one of the carbons because I know oxygen can have 2 bonds, and I can try to fit in the hydrogens around it. So let's go ahead and try to put the hydrogens around. Let's see if they'll fit in. Okay. So now I'm making sure I follow the honk 1, 2, 3, 4 rules. Each of the carbons can have 4 bonds, the oxygen has 2, and we'll put in the hydrogens. So I have 1, 2, 3, 4, 5, and 6 hydrogens there. So this condensed formula will be C2H6O, and the same thing is over here, C2H6O. So this is a correct answer. I can't draw this original one because it's what the question had given me. I need an isomer which has a different structure. Take a look at example 4. It says draw an isomer of pentane. So go ahead and draw your pentane molecule and pause me. Right, going back to table P, we know that pentane will have 5 carbons. So I'll draw it 1, 2, 3, 4, and 5. It ends in ane, so I know that it will all be single bonded carbons. So I'll just fill in the hydrogens around it. Okay. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 hydrogens. So C5H12. So this is the original structure. I have to draw something that's a little different from it. So I'm going to do that on the right-hand side. The nice thing about hydrocarbons is that you can also have them branching off of one another. So I could have the 4 carbons in a row and then another carbon coming off of it. So I still have 5 carbons, and we can just check the number of hydrogens to see if we'll end up having the right number of hydrogens. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I still have 12 hydrogens. So this structure right here is an isomer of pentane. And it's an isomer of pentane because it still has the 5 carbons, but they're not all in a row. I have 1, 2, 3, 4 here, and then another one is branching off there. Whereas here, all of the carbons were in one row. So, for as a summary, isomers have the same formula but different structure. So, rearrange all those carbons, hydrogens, and oxygens around. And here's some words of wisdom. Don't be fooled by the same image just reversed or flip-flopped. They will do that to you on a multiple choice question. Don't be fooled by having a different number of carbons, hydrogens, or any other element in there. Make sure that you have the right number of elements. And make sure they follow the same or the proper bonding rules for HONC 1, 2, 3, 4. I have seen some examples or multiple choice answers, that they give you this possible isomer. Well, hydrogen can't have two bonds, so this is not a possible answer. Okay? So, if you guys need any help, just let me know. Have a great day.